Good morning. Looks like we have a little preschool algebra to do. Let's jump in. Let me make this a little bit larger. Bam. Okay. So the name of the game here is we are trying to write these as a single logarithm. The first thing I'm going to do is I'm going to take this 1/3, which is a coefficient, and put it into the exponents here. So I could do this in two steps if I wanted to. I could write log base b of, in parentheses, x to the fourth, y to the fifth, all to the 1/3. But exponents do distribute over multiplication. And I'm really just going to end up with the log base b of x to the 4/3, y to the 5/3, minus, and same idea over here, the log base b, and pro tip, write your logs in cursive. That way it doesn't look like ng of x to the, looks like I get 6/4, about 3/2, and y to the 3/4. Now the whole deal here with the minus sign is if you subtract two logs with the same base, then you get to divide their arguments. So as a single logarithm, I have the log base b of x to the 4/3, y to the 5/3, over x to the 3/2, y to the 3/4. And when I am dividing things with the same base again, I end up subtracting their exponents. So I have 4/3 minus 3/2. It's a little bit of a pain. We could write this as the log base b of x to the, and I'm thinking of this as 8/6 minus 9/6. So I should get a negative 1/6 there. And I get y, same idea here, common denominator this time is 12. So 20/12 minus 9/12 seems like 11/12 to me. And there is that final answer. Same process over here. Notice we also have these 5s, making things a little bit on the funky side, but that is okay. So I'm going to do the log base 5. And I felt like, if I did glance at what the answers look like, but I felt like, actually expanding this out a little bit more. But that is okay. So the log base 5 of 5 to the negative 2/3, m to the negative 4/3, plus the log base 5 of 5 to the 1/2 m. From here, since we are adding these two ones, we multiply the arguments. And so I have the log base 5 of 5 to the negative 2/3 times 5 to the 1/2. And looks like I have m to the negative 4/3 m. Now I can add these exponents together. I should end up with the log base 5, and we're looking at a common denominator here of 6. So negative 4/6 plus 3/6 should be 5 to the negative 1/6, and m to the negative 1/3. A little bit on the funky side. Let me see if that's what they got. Okay, I did make a little bit of a mistake here, and that was that this was log base 5. There's a 25 there. Oh, I copied it down wrong. So that should be 25 to the 1/2. Well, 25 is 5 squared. 5 squared to the 1/2 is just 5 to the first. So let's knock out this last line here. We will rewrite this as the log base 5 of 5 to the positive 1/3, because that once again is just 5 to the first, and it's still m to the negative 1/3. That is a perfectly fine answer. The book offered 2 of them. The other one that the book offered was something more like this. The log base 5 of 5 over m all to the 1/3 power or something. Okay. Let's see. Is that what they said? Yeah, they said cube root. I said 1/3 power, tomato, tomato. All right. Hope that clears up some stuff.